We are live. Indeed. Good evening. Not sure about party. Definitely be some good stuff going on though. How are my levels? Cool. I had a good play with them this afternoon, so they should all be good now. Well, no, we don't want any music over this demonstration, I guess. Do my This seems like a good way to finish the week. Well, not my week. My week finishes tomorrow. But Fridays are always a good day for doing something cool. No, never. Week never ends. That's okay. I know what I signed up for. Lucky you. I don't have any beer yet. I may get some on the way home. Oh well, I guess we'll get started. And people can just join and drop in as they pass by. So this evening we're going to be digging a little bit into the Twitter demo that I'm sure you've all heard and seen me post about a lot on Twitter. So a bit of background on what this demonstration is for and why Twitter and what it's doing. So I had a desire to build an implementation of Cerberus that could demonstrate the claims that we've been making in our white paper, in all of our discussions, and to really showcase what level of technical ability we have with Cerberus and what the past number of years have led up to and what that means. But I wanted to be able to present that in a way that people could understand, so if you weren't technical you would still be able to grasp to some degree what's going on under the hood and why that stuff is important. So I was looking around for some ideas on demonstrations to use, and Twitter seemed like a really good one for a number of reasons. So there's a ton of data that you have in Twitter. There's 300 million users. However many tweets a second go through. I think it's 6,000 tweets a second on average. So there's a lot of data there. So that was important so that we could showcase that an implementation of Cerberus is able to handle really large, big data sets and be able to handle them with ease, right? So there's no real bottlenecks in putting all of this data into the network so long as you have a network of sufficient size. And also to be able to ingest this data, these tweets, and basically replay tweets and conversations and likes and all that kind of stuff, to be able to replay them in order as they happened on Twitter, and do them at a fairly high rate of throughput. So I'm talking 5-10,000 tweets per second going through the Cassandra implementation of Cerberus. Another thing that's important is that tweets are a really simple, easy to understand way to demonstrate atomicity in a sharded environment. What that means is if I'm performing an action on a sharded ledger, I either want that action to complete in its entirety or to fail in its entirety. I don't want some leftover state somewhere in a different shard that needs to be cleaned up or causes issues later on because it hasn't been cleaned up properly. And there's quite a number of sharded ledger technologies, and there's quite a few on the horizon as well, but none of them are able to do truly atomic commits, which is the correct term. And it basically means either all of this stuff happens or none of it happens. And you might be wondering, well, why does Twitter showcase that? It's just a tweet, right? Some taps and some text and off it goes. That's how it appears on the surface, sure. But underneath there's quite a lot that goes on, right? So if I have an account on Twitter and I want to tweet something, then I need an account first, right? I can't just go to Twitter and send an anonymous message, although that might be nice for some social media platforms to be able to do that. Twitter doesn't allow you to do that. So first thing I need to do is to go and create a user, right? And then once I've got my user, my account, my handle, whatever, I'm able then to make tweets. So that's your first part of a potential cross-shard transaction that's happening on Ledger that needs to be atomic. I want to make this tweet, but in order to make that tweet, there also needs to be a Fusilier account that exists somewhere. And that Fusilier account may live in the same place, in the same shard or shard group as the tweet that I'm making, or it may not. Now in the case of Cerberus and Cassandra, the shard space is so huge that the likelihood is that my Fusilier account lives in a completely different place with a completely set of nodes managing that part of the ledger than where the tweet is going to end up. So there's this cross-shard communication required. And there's some other things as well that you want to check, right? You want to check, well, does this tweet already exist? Has Dan already tweeted this? Or whoever the person is that's tweeting. So you potentially then have another check on the ledger. That would actually be in the same shard group as where the tweet is going, but it's another step of the process, right? If that fails, then you want everything to fail everywhere. Some other things that happen underneath the hood is any mentions or hashtags that I might reference within my tweet. Mentions are easy to understand because if I'm mentioning somebody, well then their account needs to exist somewhere. So if I was to mention Piers in a tweet that I was making, then it would need to check that my account exists somewhere, that the tweet doesn't already exist, and that Piers has an account. And if Piers doesn't have an account, then the thing fails. Same with hashtags and other stuff like the counters, simple counters of how many retweets are there, how many replies are there. If I'm replying to a tweet, then that's another check that needs to happen. Does this tweet that I'm replying to exist? Because if it doesn't exist, then how can I reply to it? Same with retweets. I can't retweet a tweet that doesn't exist, so you need to check that tweet that I'm trying to retweet exists. It's a bit tongue-tied saying tweet all the time. So just a simple tweet where I'm replying, I'm mentioning somebody, I'm putting a hashtag in there. You've got potentially 5, 6, 7, 8 different shards that it needs to touch, and all of those shards could live in what are called shard groups. And a shard group is a collection of shards grouped together that a set of validators take care of. So in the worst cases, you might have tweets with tons of mentions and hashtags, and it's touching maybe 20 or even 30 shard groups. And you don't want any single one of those shard groups to get mixed up or confused if the tweet doesn't go through. You want everybody to either commit and everybody has a copy of it and everybody knows that it happened and everybody adjusts all of the all the state accordingly. So the counters adjust and all that kind of stuff adjusts. Any hashtags, their trending metrics, all of those things adjust. Or if anything fails, nothing happens anyway. You don't want any of this kind of cleanup stuff, which is both bad for developers, because if you don't have atomicity when you're committing to a ledger, then it's on the developers largely to clean that up afterwards. So in their program code, their smart contract, or whatever it is that they've built, they need to have specific chunks of code that then potentially deal with cleaning any of these issues up. And you can run into all kinds of problems where one validator set thinks that everything was fine and another validator set thinks that stuff went wrong, and you just have all these issues. And from a user perspective as well, it's not great, right? Like for a tweet, maybe I don't care as a user too much if it doesn't go through. But if I'm using a DeFi application and I'm wanting to do a bunch of things in sequence, maybe to get some arbitrage or to do a flash loan or something, I either want all of that to happen or none of it to happen. I don't want to be left bag holding some tokens that my only reason for using them was to act as a conduit between two different smart contracts or two different applications or whatever. So atomic commits, tweets are a very good, easy, understandable way to be able to show that to people and to explain what it's doing and why that's important. So yeah, let's get into some stuff. Also, you guys that are in the chat, if you have anybody from Twitter that you would like me to find and show some of their tweets that are there, then please drop their names into the chat. But do bear in mind that this is a tiny piece of the feed that I have. It's about 4 days worth of the feed at the beginning of this year, so there isn't a great deal. Trump, of course, Trump's the first one. Let's resurrect Trump. Hey Trump, you can have your Twitter account back, but it's not on Twitter. So some people might not be there yet. You know, maybe they were taking a vacation over New Year for a few days, and so some big accounts maybe won't be there because they just haven't tweeted over that time period. So here you can see I've already got a bit of a hashtag thing up for Bitcoin. Can you put in their actual Twitter handles, because otherwise I'm going to spend half of the time doing this demo finding out their Twitter handles, because I know Pomp's Twitter handle isn't Pomp, it's something else. I think it's A Pompliano, I'm not sure. Oh yeah, okay, yeah, we know Elon, right? So one of the cool things with Cassandra is there's also a search capabilities natively built in. So usually what you have to implement if you want to search like a blockchain or blockchains or a DLT is the actual data that lives on the validators or your full node replicas don't have any kind of indexing information as such. And usually you would have the blockchain, let's just use a blockchain for argument's sake, you would have a blockchain that's doing its thing. You'd have a full node that is receiving new blocks and all that kind of stuff, and mempool and whatever. And then in front of that, you would have a big cache proxy indexing server. And then your clients would, or your applications or your website or whatever, would connect to that kind of middleman service, which holds all of the index data for where is this stuff in the blockchain, right? Where is Elon's Twitter account in that blockchain? What block is it in? What transaction is it in? And so whenever the blockchain gets updated on the full node, you have to update the index, and then whenever anybody searches, it hits the index. The index then knows where to go and look on the blockchain, so then it forwards a request to the blockchain node to say, hey, give me that block, or if you're lucky, give me that transaction or the package that holds Elon's tweet. So you've got a bit more complexity around your search functionality. And in a sharded network, you would have to have multiple of these kind of indexes potentially, because if you have a really large sharded network, one single index is probably too much for a single node to serve, right? That's the whole point of sharding the ledger in the first place. It's too much for one node to serve. So you probably won't be able to hold the entirety of the index on a single machine either. So you'd have all these middlemen services and whatever. But Cassandra doesn't need that. Cassandra, it's built in natively. It's quite crude. You can't do like complicated things like join searches and unions and all that kind of stuff, but I can just simply search for Elon Musk. And there he is. It's not all of his tweets. I've still got to filter some of this stuff out. What I really want to have here, which I think Cedric is working on, is like the proper threads and stuff. All I'm doing at the moment is I'm just going to the Cassandra network and saying, hey, give me stuff that relates to this user handle, and it just spits everything back to me. So I get everything. I get replies, I get retweets and whatnot. Who else have we got in here? Mr. Beast. Are these going to be? That sounds like quite ominous. Is that going to be safe for work if I put Mr. Beast in? Seems like it's going to be. Oh, well, he's not found. Maybe he's not popular enough, or he hasn't tweeted. Let's have a look at Antonop, see if he's here. Is that right? Yeah. There we go. Mr. Antonopoulos is in there too. So we've got his tweets, and we can also click on some of his tweets, have a look at them. A lot of these tweets that I click on, because the data set that I've pulled in for this demo is quite small in comparison to how much data goes through Twitter, most of them won't have any retweet counters or likes in the thread or reply messages and stuff like that. But we might come across a couple that do, but generally most of them won't have all of their kind of conversations happening. So yeah, you know, we can click around on various people, and there we go. There's Pomp. There he is. So at the moment, this is configured on a 16 shard network, and I always forget how many validators I've got in each shard. I think I've got, it's either 8 or 16 in each shard as well. So it's quite small. It's quite a small network, really. And how much have I pulled in? 4 days worth. In its entirety across all of the shards and all of the nodes, it's probably 250, 300 gig of Twitter data. So not a huge amount, but then it's only like 4 days worth. I've got 8 years worth to pull in. So, but this is doing distributed search across those validator sets and those shard groups, and the validators in those groups are geo-distributed in different data centers around the planet. So the real cost is latency of sending the requests around, and the search is load balanced as a kind of scatter gather. So it load balances quite nice across the network. It's not the most efficient way of doing search, but it works quite well for a first implementation. Right, let's have a look for some more people who we've got in here. Blockchain Chick. She sounds like a good one. There she is. We are at 900 billion total market cap. 1 trillion coming soon. At the beginning of January. Cool. Yeah, well, we're past that now, so that's all good. You were right. Who else? Well, if Piers is in there before me, because I didn't tweet enough at the beginning of January, so it hasn't picked me up. If Piers is in there before me, I'm going to be a little annoyed, because Piers tweets less than I do. No Piers. That's good. I'll tell you who is in here now. Check this. He'll be very happy. Of course he's in before me. Good old Shaddix. Yeah, sort of like a MapReduce on the search. Yeah. Yeah, Adam Back will probably be in there, actually. He tweets quite a lot. There we go. And a bunch of his stuff as well. He's probably, yeah, he tweets loads. We've got everybody. Radix Ecosystem. Is that the actual handle? I think it is, right? No. Radix Ecosystem. You need to tweet more. And then Cassandra would have found you worthy already. I don't know if Cameron is in. I'm pretty sure. I know Cameron is. Tyler probably is as well, because these guys tweet quite a bit too. Okay, let's take a. Let me see if there's any actual questions. They're just loads of Twitter handles. Really fast, how many knows? Cool. That's a good idea. Yeah, you could do clips and then tag them in. That's pretty smart. Get everybody chit chatting. So this is proof of full sharded 100% Cerberus, right? Yeah, it is. Almost. I've got a couple of little jobs to do until I can actually hit the commit button on pushing this up tomorrow. It's looking good for that. Then at that point, it will be a a 0.1 alpha version of Cassandra that implements Cerberus and a bunch of other cool stuff that I've built specifically for Cassandra. That'll be on the open source repo. It'll be live. So yeah, tomorrow potentially the world changes forever, because then it'll be out there. And if I was to disappear tomorrow, then after tomorrow, let's get this right. If I was to disappear after tomorrow, then there is a guide on how to build this stuff, and it's fairly complete as well. It just needs testing a lot. There's probably a lot of bugs in there. It needs cleaning up. There's a few things that some optimizations and improvements, like threshold signatures, optimizing things. It's quite heavy in terms of how much storage it uses for things at the moment, such as like the things for the certificates. They're quite heavy. I've got some work to do there to kind of compress them and make them more efficient. But generally, it's operational. Let's say, right? You could take it and you could build something out of it if you were up to speed with consensus theory and that kind of stuff. You know, if you were a smart consensus guy, you could pick it up and run with it. Yeah, I mean, we should just for the public demo. I'm not sure how much I should go into this, because Ben's been working heavily on ideas for this. But basically we can, yeah, I mean, just tag all the heavyweights in, right? Get them engaged with this demonstration. Although I think that most of the people that were banned, well, suspended over the past few days on Twitter, I think they've almost all got their accounts back now. It was just some glitch in the Twitter spam detection stuff that tries to pick up on fake accounts. So the numbers at the top, so they're not moving because this finished its import. I told it to do I think 30 million import for this demonstration. But when they're ticking over, the top bar is the throughput in terms of atoms, or in the case of this demonstration, tweets or user registrations. The first number is the average throughput per validator set that's serving a shard group, and the second number is throughput throughout the entire network. So because this is quite a small network, and on average I think a tweet touches 4 or 5 different shards, different shard groups. Generally the second number hovers maybe 2 or 3 times larger than the first one. But if we had more shard groups, so if we had say 32 instead of 16, then that number there would be like in the 80s in this case, and if we had 64 it would be up in the 160s, and so on and so forth. And then this number here, you can't really see it. Let's inspect it. This number here is basically how many tweets or user accounts on average a shard group is holding, and then the second number is how many tweets, user accounts, whatever, does the network hold in total. But these are estimates. The second numbers, and the first as well. The first and second numbers are estimates, so they can fluctuate a little bit. They're not 100% accurate. It's really hard to get accuracy on those kind of metrics in a sharded environment. So they're kind of best guesses, if you like. Is this possible on any other L1? No. It's simple. No. I mean, you could make it look like it's doing what this is doing. So whether it's sharded or not, like so on something maybe like Solana, where it's not sharded but is able to do high throughput, you could do this demonstration, right? But it's not really an apples to apples comparison, because the point of this demonstration is to show big data in a sharded environment doing atomic commits. They don't have to worry about atomic commits because they're not sharded, right? So they couldn't do the same demonstration because they don't have the tech stack to be able to do the same demonstration in a way that would be a fair comparison, right? But what they would run into if they did this demonstration is they would probably run into storage scale issues, unless all of their validators they're using in that network to do this demonstration had 100 terabytes of storage on each of them, right? Because that's about what this entire data set, the size of it is. It's about 100 terabytes. Now for Cassandra to pull all that stuff in, it's fine, because we can just shard it up to the point where, okay, each shard group is a terabyte. We have 100 shard groups, and we've got the 100 terabytes covered. But they obviously couldn't do that because they're not sharded. With sharded networks, you could probably do a convincing demonstration of this on those networks, because there isn't really any consequence if a tweet fails and you don't have atomic commits and it's not cleaned up properly, right? So in this demonstration, if a tweet left some state hanging somewhere, it's probably not a critical issue, right? It's not going to cause real problems. You know, someone's reply count is going to be wrong, or it's going to say that this tweet exists when it doesn't. So a particular tweet just won't go through for whatever reason. It's not really the end of the world for anybody. But if it was a DeFi application, right, where there's money involved, finance and stuff, that's when you run into problems. So this Twitter demonstration, other ledgers could probably do it, and do it convincingly, because they don't need to be quite as concerned about the atomic nature of things. But if it was an actual real application that had value, then they wouldn't be able to do it. Or if we ever end up doing any DeFi demonstrations on Cassandra, then the narrative that we can probably push it a bit harder, because it's like, look, you can't do this, because we could make demonstrations where things do fail, and fail in a way that would potentially cause issues in sharded environments that didn't have atomic commits. So our demonstration would be not just a success, but also forcing failures and showing that the cleanup happened correctly, and I'm not left with, you know, some tokens or whatever it was that I was doing. And so for them, other sharded ledgers, to do an apples to apples comparison, a test, a demonstration that's the same, they would have to run the failures too, and then they would start to run into issues of how do we clean this up, right? There's pending leftover state hanging here. How will I feed the 100 terabyte of Twitter data? So the way I'm going to do that is I'm going to run most of the feed injection from here for two reasons. Well, really for one reason, but let's go for two reasons. It's quite heavy, in terms of getting that feed data to everybody in the community, and everybody would need large amounts of storage in order to be able to push that feed. And secondly, I don't fancy uploading 100 terabytes of data anywhere, let alone to multiple people. And I also don't fancy paying 100 terabytes of storage on any cloud computing services to store it either. So I've actually bought some specific hardware to store all of this data on. I've upgraded my SAN. I've got a fairly decent connection here at the office where I'm able to push out to the network more than it'll probably process for the foreseeable future in terms of demonstrations. I can probably push out 20,000-30,000 tweets a second. So until our community Cassandra test network is that big and can handle that amount of load, my connection here at the office will be good enough to supply that network with more tweets than it can cope with. So yeah, I'm going to run it from here, which I mean, I'd rather if it was a bit more distributed, but practically I don't see how it can be done without people in the community having to spend money on storage and being a big time, so just moving that huge data set around. So we'll do it like that, at least to start with. Yeah, so in the feed I've got deleted tweets as well. So tweets that people have deleted, for some reason they're in the feed that I pulled. So yeah, nothing is ever deleted on the internet, and especially so if I've got hold of a tweet feed with you in it and it's going to go onto a Cassandra network. Also, interestingly, a large number of the tweets in the feed that get pushed into Cassandra, they actually fail as well. I think it's about 5 or 10%, depending on what's happening in the network and what these tweets are referencing and how fast I'm pushing them in and stuff. Because the feed that I've got, even though it's 100 terabytes worth, that 100 terabytes of feed only constitutes between 1 and 2% of all of the tweets and activity that happened on Twitter. So I've got this 100 terabyte feed that goes from, I think, mid or end 2012 to end of January this year. But that's about 1 or 2% of all the stuff that happened over that time. So what I find in that feed occasionally, well, quite frequently actually, is that there is a tweet that is maybe replying to something or is a retweet of something that just isn't in the feed. So I have to fail that reply or that retweet, because this goes back to what I was saying earlier on about the atomic commit and stuff and checking the dependencies exist. If the tweet that it's referencing isn't in the feed, then I can't process it, because if it wasn't in the feed, then it wouldn't have made it onto the ledger. It doesn't exist. As far as Cassandra concerns, it doesn't exist. As far as Cassandra is concerned, this is a bad request, right? It's a bad transaction. So I have to fail it. So a lot of things that come out of that Twitter feed and get pushed to Cassandra, a lot of stuff fails, which is great, because not only are we testing the good cases where everything goes through and everything's happy, we're also testing the bad cases, and we're testing them quite heavily as well. So 5 or 10% of things failing is quite a high failure rate. So it's not like a perfect environment where this is working within. It's actually quite bad, right? 10% of stuff potentially is failing, and so nodes have to clean up and make sure that it's atomically undone as well as being potentially atomically committed. Okay, let me scan through some of these other questions. All right, okay, cool. What are the other Radix employees exactly doing for Cassandra? Nothing really, and that's on purpose, right? So the rest of the developer team are concentrated on Olympia, that's going out the door Q2 this year, and I don't want them to be distracted by the stuff that I'm doing. So I'm essentially in a sandbox here, just working on this and working on these concepts and ideas that they will need to implement at some point over the next 1 or 2 years, as we roll out these additional mainnet upgrades and releases. So, and obviously the purpose as well of Cassandra and all of this research is aside from finding cool ways to do things, is also to validate that the Cerberus paper that we did and all that theory is viable, and there is an implementation or multiple possible implementations for Cerberus, and that just gives confidence not just to us but also to the community and everybody outside looking in, that they can play with this stuff a little bit before they otherwise will be able to. Next steps. There's quite a lot to do, but nothing really major in terms of big components that need to be implemented. All of the kind of fundamental stuff that's required is there. The sharding stuff's there. The two-phase consensus that nodes use locally is there, which isn't hot stuff. It's a novel hybrid, which is something I've been looking at and playing around with for some time. The state machine, the state engine is there, which that's very important because managing state in a sharded network is quite tricky. You can get into all kinds of nasty deadlocks and race conditions if you're not managing it correctly. So I also wanted to implement a state engine so that my research in that now could feed into the guys that are doing the current Scripto research, because they need to know that, okay, this idea that we have for how this particular piece of Scripto might work, does that violate any kind of state constraints that we have, or does it cause a race condition or something like that? So me doing the state engine and state management stuff now and figuring out how all that needs to go together, that's something that you'll see the benefit of in the more short term, right, with Scripto and all that stuff. And so the guys that are working on Scripto at the moment can look at what I'm building here and be like, okay, cool, so this way works, it's been tested, etc. So we need to make sure that we don't violate any of these fundamentals over here when we're designing and implementing the Scripto stack. So yeah, like all that kind of big stuff is done. It's a lot smaller stuff now. Like I said at the beginning, like optimizing things, improving messaging complexity and vote complexity, implementing threshold signatures, optimizing the data stores so that the data structures are more compact. They're quite bloaty at the moment, but they're bloaty so that if anything goes wrong, I don't have to kind of work hard to try and figure out, okay, what's this piece of stuff doing? It's just there, right? It's very verbose. But yeah, it's finding bugs. Right? There's going to be a lot of bugs in this thing. There's still quite a bit of pen testing that I want to do and test the security model and stuff. I've already done quite a lot to kind of test the broader theories of things. So there's like these kind of catch-all things that if any of these things fail, then your consensus is broken. And so kind of done all those first, and a few edge cases that I thought of that might be tricky to deal with if they failed, but all of that went through okay. There's still a million other little things that need to be tested properly and stuff. But yeah, I mean, from this point forward, really, it's just kind of building that code base, building the maturity and some of the new stuff that's been developed and built for this, testing it, pushing it a little bit, build some more features on top of it, optimize things, and make the API better so that we can do some more interesting demonstrations later and stuff, and just really hone things up, and then just do a ton of security testing and all that kind of stuff so that we can have 100% confidence that this thing is absolutely solid. This implementation works and it's 100%. Cassandra will be up and live in some some manifestation for a long time. Let's put it that way. So like, you know, this Twitter demonstration probably has a shelf life of a few months, right? And then maybe there's some other demonstration that uses some new cool features that have been built into Cassandra, or there's something in the crypto spec that's like, hey, Dan, can you just prototype this to make sure that, you know, this will work with the state engine that we're using? So, you know, there will always be something with Cassandra going on, some kind of demo, some demonstration, some technical progress, up until the point where it's no longer needed. But I see Cassandra running alongside and slightly ahead of the mainnet for at least a few years. Yeah, so Tempo, even though the implementation direction we were taking had some issues, right? It had the weak atom problem, and we inadvertently weakened the Sybil mechanism by some decisions that we took away from the original specification later. Even though those two things were resolved, Tempo didn't have atomicity. So even if we had never had those issues that kind of threatened the security of the implementation we were running with, we still wouldn't have gone to market with Tempo because there was just no elegant way to do this kind of atomic commits, atomic composability stuff. So I mean, there's a lot of ideas that have come over from Tempo and all the other iterations, but yeah, Tempo wouldn't have been fit for DeFi, at least, or at least not easily. Yeah, the entire code base will be up on GitHub tomorrow. There's a couple of things I'm not going to commit, like the application that pushes the Twitter stream in and stuff, really because it's not really relevant to Cassandra, and it's a bit of a hack, to be honest, the way I've put that together just to get the job done. So there's a few bits and pieces that I won't be pushing. Some really experimental stuff as well. I'll probably keep those back for a little while, but that doesn't prevent anybody from pulling the repo, building it, being able to spin up, you know, a Cassandra node or spin up their own little network and stuff. So what's up there will be fully functional, just not commercial grade, right? Don't build anything on it or with it, because I've built that entire thing in 4 months, almost twice in 4 months, because mid-January I went back to a clean code base because the FlexCon code was just rushed together. So yeah, essentially built it twice in 4 months, and there's a lot of stuff in there that's new as well, so it definitely isn't mature for anything. If we want to do a really high throughput demonstration, loading in tweets and having them processed across the Cassandra network, then it will have to be a distributed delivery method. Yeah. So, you know, if we're in the position where the community or someone's sponsoring the demonstration or something is like, hey, you know, spin up as many nodes as you need and go as fast as you can, pushing and processing these tweets over Cassandra, then you know, if we were looking at 100,000, 200,000 and beyond, then it would have to be a distributed delivery system, at which point, yeah, we'll have to put some architecture together for that. Why are we going away from hot stuff? There's just a few things where, and this isn't just hot stuff, right? This is relevant to all of the kind of classical consensus mechanisms where you've got a quorum and they're voting and you have a leader, or these kind of multi-phase leader systems. And there's a few things that just get tricky to resolve if they should happen, right? So one of those things is if you get a liveness or safety break, they're really difficult to resolve with those kind of consensus mechanisms without having some authority, right? And if you don't want some authority to be able to come in and kind of put the network straight and restart it again, if you want to do it permissionless, and if you want to do it decentralized, that's a really difficult problem that opens up a lot of edge cases and a lot of potential attack surface if you don't do it correctly. And so looking away from what we're using for Olympia hot stuff is, okay, how can we potentially resolve some of these issues around safety, liveness, possible security breaches, and all of these kind of things, and as well that those issues get even more tricky when it's sharded as well. I mean, they're quite difficult to resolve in a unsharded environment, but it's easier than having to do it potentially in multiple shards and all this kind of stuff. So while we have solutions that will work, they're not ideal because they're quite complicated. So the purpose was part of Cassandra's mandate, if you like, was to kind of, okay, let's take a step back and look away from these purely traditional classical consensus mechanisms that live underneath Cerberus, and let's look at something a little bit different. And it's been known by us and the team for quite some time that the local consensus, if you like, the group consensus that the validators take, doesn't have to be hot stuff. It doesn't have to be PBFT. It could be Nakamoto, right? Or it could be something else. All that really matters is that the output of those rounds of consensus, the primitive that is produced from them, are compatible with the Cerberus protocol. So you could even have one shard group using hot stuff, another shard group using PBFT, another one using POW Nakamoto. You can have very flexible underneath what is the consensus mechanism that the validator sets are using, and that can be a bunch of things, right? You could even have consensus by conference call, so long as you produce the right information to give to Cerberus. So knowing that, it became, okay, well, let's just see if there's some better method, more elegant solution maybe of local consensus that we can use underneath Cerberus that maybe mitigates some of those complexities later. Also as well, like Cassandra's method of local consensus allows for much larger validator sets as well. And there's no leaders, which is the other thing as well. So dealing with leaders, the failure of leaders and stuff, in these classical consensus mechanisms, that's where most of the complexity is in them, is what happens if the leader or primary that's driving consensus forward, what happens if they crash, what happens if they disconnect, what happens if they're malicious, what happens if they're dishonest, how do we orchestrate a new leader to take their place, and how is that safeguarded, how do we deal with timeouts, how do we deal with all these kind of edge cases and failure cases around the leaders. That's where most of your complexity in these leader-based consensus mechanisms are. So if you can also kind of sidestep around that and make your local consensus leaderless, then that just saves a lot of complexity as well. So what Cassandra is kind of the best of both worlds, right? You've got the probabilistic side, which is very Nakamoto-ish, which gives you some really interesting and nice guarantees around liveness and safety. And then the second phase is more akin to a classical BFT, where you get the really strong safety guarantee. And you put those two things together, and you have a much more powerful, elegant, and resilient consensus mechanism with a lot less complexity. But that's, there's still work to do there. But thankfully we've got quite a bit of time before fully sharded Cerberus Radix mainnet is out the door. So what have we got? I mean, maybe you could have subsections of the network have like different consensus for dApps and stuff, but the idea here is just to make it so that you don't have to worry about that, right? So basically make it so that the consensus that's underneath Cerberus, that's doing the local consensus, and Cerberus is dealing with all the cross shard stuff for you. You don't need to do anything with it. It's as good as, if not better than, anything you as a developer could produce. So why would you worry about it? Why would you worry about implementing your own? Again, you mean like the mixed consensus and stuff, or just Cassandra's consensus? I mean, yeah, there's nothing that I know of that has these kind of features, right? I don't know of any hybrid consensus mechanisms, and not just in the crypto space. I mean, like anywhere in academia as a whole. I don't know of any, and I've spoken to a couple of professors as well, to see if there is any kind of precedent on this stuff that I'm looking at. And there are none of these hybrid consensus mechanisms where you're leveraging the best of both worlds, but doing so in such a way where it ultimately makes it stronger and more resilient to faults and attacks and all that kind of stuff. So, this is beyond the cutting edge as far as I'm aware. So the peer review is still going on, but COVID really kind of stuck a spanner in that. So it was submitted. When was it submitted? I think it was submitted last summer, or late spring. Late spring it was submitted, and it was put on a fast track. So we should have got the peer review completed by October. But COVID-19 disrupted everything, right? So it's still moving along, but there's no ETA at the moment, which is unfortunate. But it's considering the state of the world right now, it's probably the least important thing for anybody to really be worrying about. So yeah, it'll come when it comes. Okay, so how are we doing? An hour in. Right, let's show some more of this interesting stuff. So let's bring up one of Cameron's tweets, and let's have a dig underneath. I need to refresh, and I'll get my data. Okay, so this is data that's come back from a Cassandra node validator somewhere out there when I've searched for Cameron's tweets, and then I've clicked this one, and that's then found that from whichever validator node could serve it to me. And this is the information that comes back, right? So it looks like a lot, and it looks complicated, but it's not too bad. We're not going to dig too deep into anything. So we have an atom, and an atom is kind of like the box for things, right? So you've got some stuff that you want to do in the network, then you put them all in an atom, and an atom is like the box. And atoms really are just quite, they're very minimal, and they carry these things called particles, and particles are the things in the box that want to do something, right? And so in the case of this tweet, the type of particle is a tweet particle, obviously, and that has a bunch of fields that describe this particular tweet. So there's an owner, which is a public key, which has been generated on behalf of Cameron in this case, because I don't think he has a Cassandra public key. If he does have a Cassandra public private key pair, I would like to know how he's managed to get his hands on one, because they're not readily available at the moment. So this has been generated for him just so I can process stuff in. Then we have hashtags that have been extracted from the tweets. As you can see, there's a Bitcoin hashtag there. The consumable is can this state that this particle represents, can it be consumed, right? So a consumption of state, if you think about when you spend, like you make a spend on Bitcoin, right? You have these unused transaction outputs in the UTXO. And so if you had 10 Bitcoin, you would have a transaction output that has not been consumed yet. And then when you spent that to somebody, you would consume that transaction output and you would potentially get a new one back that was your change from the transaction. So if I was sending 5 BTC and I had 10, that one would be consumed. I would get 5 back that was now unconsumed. Make what bigger? This? Does that? Like that? Is that better? Yeah, I'm guessing some of you guys are maybe on phones or small laptops, right? So yeah, so when you spend, you consume. Now, can't really consume a tweet. Well, yeah, so we thought, right? Turns out that maybe you can these days because you can make an NFT of it. But for the purposes of this, we're going to pretend that tweets aren't consumable and in Cassandra land can't be turned into NFTs just for our sanity. So a consumable just says whether this thing can be consumed or not. Now, consume might not just be spending; it might be a bunch of other different things like an ownership change of the account. Right, this could represent an account. So you have an ownership change, which means you would consume the account and then instance a new one of it to a new owner somewhere else. The spin is it tells the ledger what state the particle is in, right? So in the case of a spend, let's go back to using a spend. If I have an unspent transaction output, then it's both consumable and its spin would be up. And up says this thing is, you can use it, right? You can do something with it. It exists. And if the spin is down, it says this thing has been used. Something's been done with it. An action has been performed against it. It existed. So you got exists and existed. But you still want to keep it around, right, for historical purposes, right? So, was this thing spent? Did it go into the downspin state, etc., etc.? So in the case of a spend, if I've got an unspent transaction output, then these fields would be consumable true and spin would be up. Then when I spent it, I would get there would be a change to those fields on that particle where consumable would then be false because I can't consume it now because I've already consumed it, right? I've spent it already. And the spin of this particle state would also then be down because I've used it. So that's kind of how the state transitions are managed by those two fields. And with just those two fields, consumable true or false and spin up or down, you can essentially do anything with just those very simple spin and consumable logic flows. Created at, well, that's pretty self-explanatory. Then we have the ID. Now I've tried this a few times and it doesn't always work, but let's give it another try. So this ID that you see here, I get tweet IDs in the feed, which makes sense, right? So I wanted a means whereby I could, in the public demonstration, I was able to show that these tweets have come from Twitter and are also available on Twitter. So what I wanted to be able to do essentially was, if somebody was using this demonstration and they came across this tweet, that they would be able to go to Cameron's account on Twitter and find that particular status. Now, for some reason, this actually doesn't always work, but I'm gonna try and find that tweet on Cameron's actual Twitter page, and then send you a link to it. This might take a few minutes because this guy tweets a lot. Seems a real lot during February. There must be one. There must be one that works. We've got another one. Let's have a look at this. Can you? This is something that I don't think I've ever done on Twitter. Can I search for actual text? Seems I can. Now what's interesting is that my ID somehow has got malformed. But there is that tweet. Oh, you found it exactly the same time, Peachy. Well done. So I've obviously broken this at some point, because in the past I was able to just copy that status ID out and put it into Twitter. On the URL bar, and it would take me straight to that tweet. So somewhere along the line, that's malformed somehow. But anyway, yeah, there you go. Me and Peachy have both found that tweet independently at the same time. So I wanted to have that so that people can verify things, right? So I mean, some people will see tweets in there that they've created and be like, oh wow, yeah, I made that tweet. I remember tweeting that, and all these replies and stuff. But some people might just be thinking, you know what, this is probably just all smoke and mirrors, right? So let's go and actually have a look on Twitter and see if all these tweets are there. And it's like, oh shit, yeah, they are. Wow, okay. So that's why I wanted to keep that ID in there and kind of use it in the ledger, even though it costs me because I have to include another shard, right? I'm storing this tweet ID now alongside these tweets, and that tweet ID maps to a shard somewhere that's in some shard group. So I need to go and check that this tweet ID doesn't already exist, because I also get duplicates in the feed for some reason too. So some tweets are in there multiple times, and if I try and insert them multiple times, then, well, I don't want that. So I check the tweet ID too. Just clones of Peachy. Could well be, but I've met Peachy, so I don't think he looked much like an old HP Blade server. So yeah, I don't think Peachy is a node. Okay, right, now I want to go back to this tweet and pull up all of that info again so I can continue to run through it. We'll come back to all that stuff in a sec. So that's the tweet ID. I need to figure out why that number is now wrong, which is rather annoying. There's the text of the tweet. You can see I'm not actually processing them properly yet. Oh, it does that every time. So I need to cut some code that does them. The nonce, it's just a means for, basically that's just a unique value for this particle in the network. The user is, well, Cameron, obviously. So that touches a shard, because that gets mapped into shard space, as we'll see in a sec. And then that's just the hash of that tweet, which will get checked to make sure it doesn't already exist somewhere. And if it already exists, then it just won't push that through. So that's your kind of tweet. Now this is the important stuff, right? So the certificates that hold the consensus output and the consensus information and all the agreement that happened between the nodes. they all delivered by certificates. So we have what's called an atom certificate and we have state certificates. And the difference between the two is that a state certificate is produced by a validator set when it's performed the state transition instructions on some particular state and they've decided that either it's good to go or it's bad. And between them they produce what's called a state certificate and gossip that around to the other shard groups that are involved in this particular tweet, right? So this is the Cerberus part now. So in this case, there is a state certificate produced, and the decision was positive. And there's some proof attached to it, which this one of the things I've got to finish off tomorrow. And it references what block it was in that shard group. It says what type of state it was. So in this case, it was a state field, and the state field represented the number of retweets. The atom that it was contained in. Powers is to do with vote power in that particular shard group. They get communicated around as well. The hash of the certificate, and then some signatures of the validators that voted on this thing. Now these will be threshold signatures in the real near future, but for now I'm just using good old elliptic curve signatures to do this stuff. So these state certificates will be produced for every piece of state that is touched by this particular tweet, right? So we've got a state field, which is a value, a counter in this case, retweets. So that lives on some shard somewhere in some shard group. Then we've also got some state addresses. That's probably either does this particle exist or does this user account hash exist. We've got another state field, another counter value for replies. We've got state address, which maybe I think that could be the ID or some other unique information that either should or shouldn't exist at the time. And just each of these pieces of state that need to be verified that either exist or don't exist or need to be incremented or set or fetched or whatever has a state certificate produced for them. And then when there are state certificates for all of the pieces of state that are being used or transitioned, they all then get packed into what's called an atom certificate. And the atom certificate then goes on Ledger with the atom that contains this tweet in all of the shard groups. So all of the validators that are involved in this on all these particular shard groups that have processed all of these states and produced state certificates, this tweet will be saved on all of those shard groups and all of those validators. And so what does a state certificate do, right? So the state certificate does two things, maybe three. Hold on, we'll count as we go along. Sometimes I get confused because the state certificate and the atom certificate have similar use cases. So let's find the where's the for the retweets. This is an easy one to explain. So in the case of Cameron making this tweet, the retweet field, it gets initialized to 0. If there was an actual retweet of this in here that had gone through, then in that atom that contained that retweet, then this value would probably be incremented, right? But Cameron's made this tweet, so we need to initialize the retweet field, the likes field, the replies field, etc. So what this state certificate from this set of validators, whoever they were, is saying is that they're initializing the retweets field. It doesn't exist already somewhere that they know of in their shard group. It's not there. They've created it and they've set the output, the value to 0. And there is no input field, right? So you see on this one there's an input field. Well, there is no input field for this because it's being created. There was no input, it didn't exist before. They decided that the decision is positive, it's good, this doesn't exist already, so we can create this thing. This audit will hold a Merkle proof for where that is in their state tree, which is the thing I've got to do tomorrow. Then we got the block. Then we got some information about, what is the actual thing that these guys were checking, right? So there's two things. There's a state field, which is basically variables. So particles and objects and stuff on Ledger can have fields associated with them. And the other type is an address, right? So an address relates to something that is unique, such as Cameron's user ID, or the hash of this tweet, or the tweet ID that gets injected from Twitter. So a state address is an address to something unique, and a state field is a variable that can be used in subsequent kind of state transitions for this tweet. The powers is a compact representation of the vote power that all the validators in that shard group have, so that when I receive this and I receive the signatures for it, I'm able to figure out, okay, these guys, whoever sent me this state certificate is claiming that the decision was positive. But if the decision was really positive, then I should see a supermajority of vote power that is in that shard group backing this decision. So the powers is a compact mechanism by which I can validate that the powers that claim to have voted on this thing, and the signatures that control those, that vote power that's represented by that, and there's a bloom somewhere as well that goes side by side with this, so that I can verify my end that there was indeed a supermajority of vote power that backed this decision from n number of validators. I don't just take somebody's word for it. And the same happens in all the other state certificates. There's an input if the thing exists already. And now what's important is this execution, right? So when a validator is validating something in Cassandra and it's a cross-shard event, there's a bunch of complexity around the state model that I had to figure out. Essentially what happens is I've got some state here that I'm responsible for. It's in this particle, that's in this atom, and there's a bunch of other state as well that is being referenced. So that might be the number of replies, the number of retweets, the tweet ID, all that stuff, right? And what I want to be able to do is to go and collect the current values for all of those states. How many retweets are there right now? How many likes are there right now? Does this ID exist or not? I want to go and provision all the current values for all those state fields and addresses, and then I execute in its entirety whatever the particle logic is for this tweet, right? So in the case of a tweet, it's fairly simple. It's, does this thing exist? Does it not exist? Increment this counter if it's a reply, increment this counter if it's a retweet. Really quite simple, right? And this execution hash here is the execution output of all of those state transitions. So I've got my actual state transition output in the certificate, then I've got an execution hash which represents all the state transition outputs that happened within that particular particle execution. And if you notice that all of these execution hashes are the same in all of these state certificates, right? So it starts 3AE8 and N6E, and it starts 3AE8 and 6E. And that means that all of the validators in all of the shard groups have collected all of the state inputs, and they've all executed, and they've all come to the same conclusion about what this particular particle does, right? So even if these guys agreed that the outcome was positive, if that hash output there was different to what these guys, these validators, had as their execution hash, then the transaction would fail. Because these guys will see, hold on, your execution hash is different to ours, so what went different for you, and vice versa, right? And obviously you don't want to commit if you have different execution hashes, because something screwy is going on somewhere. Someone's faulty, someone's sending duff information around, someone's sending bad state inputs around. A neutrino's gone through a set of validators just at that moment in time and screwed up all the register values or something, right? Could anything. So The execution hash is a representation of the execution on all the validators, and that has to be the same across all of them for it to be accepted. If the commit is aborted, then you either need one of those to be different in any of these state certificates, or any decision from any state certificate is negative, right? So if you've got 100 different shard groups that a particular thing is referencing and executing on, you might have 99 of them that say, yeah, this is good, but that one where it failed, that one where it wasn't good, that vetoes everything else. Because if you were to ignore that one saying, hey, no, this is bad, and go ahead with it anyway, then you would have an inconsistent state across your network, which would cause problems later. So yeah, Radix is neutrino proof, Chadix. Well done, glad to have you here. How long have you been here? You've been here for a while? Maybe he didn't see that Cassandra thought he was worthy and not me. So yeah, so this stuff, there's these state certificates, these atom certificates. That's all of your kind of Cerberus layer that's going on, and then yeah, I think that's pretty much it. I don't think there's anything else really to cover at a high level of what's going on underneath. Oh yeah, here are all the powers, right? So the powers that was referenced up there. So what this is saying is that in this, I forget, they're the shard groups. So in shard groups 12 and 13, which is what, oh wow, this was a lucky one. So all of these state transitions just happen to land in 2 shard groups, which is quite rare. But basically what this is saying is that this is a representation of all of the vote power that is in shard group 12. And this Bloom filter gives you the ability to extract who has what amount of vote power in that shard group. And the reason it's done this way is twofold. This one actually is 2, right? There isn't any hidden ones later on. Is that it's more efficient in terms of space to do it this way. So if there was 1,000 validators in shard group 12, then I would have to, if I wanted to send like a big list of, okay, these are all the validators in shard 12, these are all of their vote powers, then, and if there was 1,000 of them, then I would have to send 1,000 public keys, which are 33 bytes each, and I would have to send 1,000 64-bit integers that represent the vote power, right? So that's 8K, 1062K. So that would be 40 kilobytes used to represent the vote power that's in that particular shard. Whereas here, this is using 28,000 bits, which is quite a lot less. I think that's about 7 kilobytes. If I remember rightly. I know, that's even less. It's 3.5 kilobytes. I know where I got 7 from. So basically gone from 40 kilobytes to 3.5 kilobytes. So massively more efficient in terms of what's being sent around. Now obviously there aren't 1,000 validators in these shard groups, so that could actually you could chop quite a bit off that by setting this expected value to be actually how many validators are in this shard group. So if there wasn't 100, if it wasn't 1,000, if there was just 100, then you could chop quite a bit off that. That probably dropped down to about 20,000 bits with 100. And it's a Bloom filter, so it's not a linear increase or decrease. It's logarithmic. So that's one reason. It's much more efficient to pack them that way. And secondly, it has some semi-zero knowledge proof properties where this Bloom filter and the powers hash doesn't tell you anything about who's in there, right? You have to have an idea of who's in there. You can't just say to this powers data structure. Tell me all of the validators that are in shard 12 and tell me all of their powers. It doesn't work that way. I have to interact with this Bloom filter using the powers hash and the data that's here, and knowledge that I know from the state certificates to figure out, to extract, okay, who's a validator here, how much vote power do they have. But the way that validators announce themselves to the network, then I'm able to leverage the fact that I can pack the vote power information in this way, because I basically know I know enough of the validators in any of the shard groups at any one time to be able to extract enough information from that Bloom with the powers hash and previous knowledge that I know through signatures and state things that have been sent, to be confident that I can determine if that was a supermajority vote or not. There's a lot more technical detail around how that works, but that's kind of the high level stuff. And now we're done. So all of that stuff that I've just spent the past 30 minutes explaining, all of that is happening for just a tweet, and then the replies do the same thing and everything. But hopefully that kind of high level-ish rundown of what's going on in here kind of flips the switch on what it means to be atomically committable or not, right? And how it all fits together so that it can be like with the execution hashes and all that kind of stuff, and why it's important as well. So that's a bit of a sneak peek underneath the hood. We've seen a few people. That's probably enough, I think, for a simple demonstration. We can search for hashtags. We can do mentions. It's pretty quick. A little search. We talked about the security model a little bit, state model. I think it's good for any demo, in my opinion. What do you guys think? In terms of what, development or what? I mean, we've already spoke quite a bit about the next steps in terms of the development of it and the tech and stuff that I've got to do. It's just all of the the little bits and pieces that I've got to finish: the testing, the cleanup, the optimizations, more testing, security testing, pen testing. There's quite a lot of stuff actually aside from just pure development. Also working on some presentations to explain some of the Cassandra concepts that are either new or are tricky from a Cerberus point of view. So some presentations on Cerberus and some of the consensus stuff that I was talking about, the novel consensus stuff, the Cassandra proof of work method and why that's cool and why that's important. So I'm putting together some presentations for stuff like for that, which I plan to do a Twitch on, or maybe even an interactive live stream or something with a couple of guys. Then also kind of writing all of this Cassandra stuff up in technical documentation, technical documents that explain how it works and digs into this hybrid multi-phase Nakamoto classical consensus mechanism that pins underneath, and also write that stuff up as a academic paper as well, and get some peer review on that just to make sure I'm not completely crazy, and that it is doing what it should be doing. That's something I'm probably going to work quite closely with Professor Sadogi and the UC Davies guys over the next few months. Just really drill into all of the kind of theoretical side of stuff, as well as the empirical implementation and all those kind of tests. But in terms of the heavy lifting of development, pretty much there. It's all smaller tasks, important, but hopefully no more marathons. The marathons are done. Alright, cool. I guess oh wait, there's a question I missed. Um, no, because nobody can understand my intellectual property, right? Like, it's not finished, so unless you've got a copy of my head, then it's only as good as it is right now. It's a bit arrogant, right? But basically, I'm not too worried for a number of reasons. Like number one, it's definitely not ready for prime time, so it's not like somebody could take that code base and just release a coin, right? Because there's definitely bugs in there. I rushed this in quite a lot of places so that I could just get to these demonstrations and start to build a bit of narrative around it and do it publicly, like facing forward. So there's definitely things in there that are wrong. There's bugs. There's probably some critical issues in there that need to be found and fixed. So if anybody was to go and take that code base and try and build a product out of it, yeah, that's a huge risk, right? Number two, it's obviously my intellectual property, Radix's intellectual property, right? It's not like it doesn't exist to anybody just because it's out in open source. There's still licenses attached to it, right? I can't just take it and claim it's mine. So, kind of backed up there from a legal point of view as well. And I mean, yeah, there's those two things, and it's not finished. So, unless you know what I'm thinking, then you're not going to be able to finish it off in the way that it needs to be finished. So, and if you stole it, I'm not going to tell you, am I? So, yeah. What's a Twitch affiliate? I'm like complete noob at this thing, right? I've only ever heard about Twitch twice. Once at Y Combinator, because the guy who started it, either he was one of the C-level guys there, or the guy that started Twitch came in. Can't remember. And through our wonderful Adam Simmons, who was a prolific Twitch streamer in his day, apparently. So I'm brand new at Twitch, so a Twitch affiliate, if that's a good thing, I'll have a look at how to set that up if some of you guys would like to do whatever Twitch affiliating is. Sounds good. Right then, so I'm going to bugger off, get a cup of coffee, wrap up a few things, then go and get that beer. Have myself a nice beer this evening. I'll see you guys tomorrow at some point, I guess, for the all being well. If nothing mad goes wrong between now and tomorrow evening, then we're in good shape right now to do the big commit, and also looking good to do the community test network trial run. So yeah. See you all soon. Thanks for signing in. No, tuning in. That's the word I was looking for. Thank you for tuning in. It's been a long day, right? I've been up since 6 a.m. Ciao.